Okay, in this particular video, we're going to take a quick look at mesh convergence. It's probably worth trying to define what mesh convergence is. So it's basically a solution that's independent of mesh design, mesh refinement. And it's also a mesh that doesn't force you or allow you to do unnecessary calculations. So too many or too refined a mesh. In order to do a mesh convergence study, you need solution information, so a key variable that you're trying to measure, but you also need mesh information. And mesh information is usually the element count. Once you have that information, you can put it into a table and plot it. If you look at this plot, it has mesh elements, number of mesh elements on the x-axis, and displacement. So this is a variable structures problem where they were trying to figure out what is the proper displacement of a particular object under load. And so the model results show how it changes with different numbers of elements, and at some points it stops changing, and so it's considered the right model. If you go too far beyond this gray region, sure, you might not change the final result, but you're doing a lot of extra calculations that you don't need to do. So let's go over to here and see our problem, the burn injury problem. In order to get mesh information, I'll go back here, maybe pop up, or look at just to pop out of here a little bit. So what you do is go into mesh. You might right click and find some statistics about that mesh. This gives you a look at the entire geometry when I right clicked and asked for mesh statistics. If I wanted to zoom into domain 2, shown here, I can go domain information, click on that domain, and we have 42 quadrilateral elements in domain 2. So let's assume that that's not enough information, or not enough refinement, I should say, for that mesh. So we're going to make the mesh even finer, and so what we could do is well, before we do that, let's see what the temperature that was calculated with this mesh actually is. So what we'll do is use a derived value, right click, average, surface, because it is a 2D problem. So we do have a surface. Click the domain. Don't ask for all times. Pick the last time. And I think we're in pretty good shape. I don't care if it's Kelvin or not. And hit evaluate. And you should see a table populate down here in the table window, or output window. Okay, so at 15 seconds, it's 33,787 Kelvin using that mesh. So let's change the mesh, go to a new distribution. Instead of 20 elements, let's go to 30. It's fine to do the element ratio. The element ratio is the ratio of the first to last element going in a particular direction, and you can reverse the direction as they've said here. And now what we can do is build that selected. You should see the mesh refine. Okay, yeah, you saw it get a little bit more dense, a little bit more refined, and now we're ready to solve this new mesh, and we'll check after we solve whether or not that affected the temperature. So we go into study, right click, compute, and let's see, as it's computing, let's see, is it setting it up? Yes, you can see this green bar down here, and eventually in the graphics window you should see a convergence plot. When the convergence plot isn't behaving this way, in other words, it's behaving either erratically up and down or progressively increasing, you know that the problem will not be converging, and you can certainly stop the solution process. But this particular problem is well posed. The grid is only slightly more refined. I'll give you an exact number soon once it solves. And we should be in good shape. So it's 50% of the way there, and it's going to accelerate. And let's see what the final, okay, so this is final look at that solution with a slightly denser grid that we showed here. What was the temperature? Let's go down to surface average value. Once again, it's got the proper domain. If I evaluate it at the last time selection, hit evaluate here, it'll populate another column to show me if there's an impact to that mesh. So we go here. Okay, so there's no impact to that mesh. We don't know the exact change in the mesh. Before, remember, it was 4200. You can come in here, right click, find out what that new domain is, and it's, instead of 4200, it's 6300 quadrilateral elements. So going from 4200 to 6300 elements made no impact on the temperature calculation. So this is equivalent to being beyond the gray region where you're doing unnecessary calculations. So let's try to go the other direction and make the grid more coarse, and I'm going to pick an extreme value just for the sake of time. So I'll pick, instead of 30 elements spanning, let's pick 1. So if I pick 1, I build all. You can see it's certainly a lot more coarse in the Y direction. And what we'll do is rerun the study. Let's do it again. Right click, compute, and this should run even faster since we've eliminated a lot of elements. And once we have that answer, we'll also be able to grab the mesh properties, and we should be in good shape. Okay, so there it is. It's accelerating. Okay, so this is the solution now. Okay. Go down to derive values, surface average. Once again, it's set up properly. It's looking for the last. It's got domain 2. If I hit evaluate, I would expect the temperature to change. So it's changed, and only slightly, but that's exactly the kind of impact that you'll expect when you do get to a mesh that is too coarse. So how coarse did it become? We go back to mesh, we right click, statistics, still domain 2. It went down from 6200 to 210 quadrilateral elements. So I hope this quick, but I hope useful video can help you with your mesh convergence problems. Please reach out directly if you have any additional questions, and I appreciate you